So like Derek said, NATS has become quite a versatile tool now, and it can be used for all sorts of plumbing, but it can also be used to extend systems and build new ones. And I want to show you how you can use NATS and OpenFaaS as part of what we're calling the PLONK stack. It's something a bit like what we had with Jamstack and MongoDB. And in the past, as Derek kept saying, we've got quite a rich history here, the LAMP stack. Okay, and we'll just jump right in. First of all, I'll look at OpenFaaS and NATS, and they make up this stack called PLONK. And each one of the projects is a letter, and actually most of them are CNCF projects. We'll then see what NATS does for OpenFaaS, like what capabilities and superpowers does it get when they're put together, and then what future work is there that we could do along with a quick demo. And if you want to tweet anything or take a screenshot, it's at OpenFaaS or at Ellis UK on Twitter. So this diagram might be one that you've seen a fair amount, and basically want to tell you that when we start talking about serverless, it's often helpful to get past the initial misnomer. We're not really talking about literal concepts, just like a cloud isn't really a fluffy thing in the sky. What it means is that the complexity and size of our system is actually getting smaller, and the concern we have for the infrastructure and how much as developers and even IT ops we need to get down to the nitty-gritty of switches and bare metal just gets further and further away. So we think of it as this kind of continuum as a universe is expanding. What that means is that you can then focus on the code that you're writing instead of looking into how are you going to provision your bare metal, what's the best Pixie boot at the moment, what ISO image do I need to be using. And that also means that things get smaller. And when they're smaller, they've got fewer responsibilities. Monolithic applications, which may well be suitable for you today and your current business purposes, are very big. They do loads of things. So if you make one change, the blast radius is potentially very big. Microservices take that down a little bit, but they tend to be quite cohesive. So you might have a customer service. And with functions, we're getting even smaller, and we might be looking at something like a customer email function, right? And so we're breaking things down. And that means that we can start to drive them through events externally using things like NATS and Kafka, different events, or we can invoke them just as we've always done over REST. Okay, and so both are important and they're both equally valid. That means that things just get a little bit easier to manage. In particular, if your code is stateless, it's a great candidate for being a function because you're really probably just transforming an input and giving an output, or maybe you're working with an external system and you'll bring some data back. We'll see an example of that later. And so those kinds of applications are super easy to scale, right? Because you don't have to worry about what data is underlying. And they're isomorphic, which means that every function that you have to manage is basically the same interface and contract. HTTP on a set port in a Docker image. And if you can make your code conform to that or use one of our shims, you can deploy it in OpenFaaS, right? Or potentially in any other serverless framework. Now, serverless didn't start with OpenFaaS. There's been a reasonably rich history here going back maybe a decade. We look at things like CGI bin and think maybe they're very similar. Now in the cloud, Amazon probably led the way here with Lambda, but there's a problem, which is that if you want portability between Amazon's cloud and Google Cloud, you have to change a lot of things. Now there's a JavaScript framework called Serverless Inc. that is designed to try and smooth that and paint over the cracks, but it's not enough. And actually you'll find different regions available, different pricing, different upload formats, different language templates and versions supported. And when you come to the enterprise, you really haven't got any options, right? What if you need a microservice instead? What if you need to run part of that on your own hardware? It's not an option for you. But actually there is, and that's Serverless 2.0. If we look at the previous generation as a 1.0, they did great things. We can stand on their tall shoulders, and now we can run any code as long as it conforms to this interface. And we can run that anywhere because we're using Docker images. And Kubernetes, which is the K in the PLONK, means that you can run that on a Raspberry Pi, you can run that in your private data center, you can run that on Amazon's cloud, or you could run it in all three at the same time and still have connectivity. And auto-scaling is also part of this equation, whether that means adding in cloud nodes automatically, provisioning new VMs, or maybe even just scaling down to zero. It's all supported, and so you're not losing any of that. In fact, OpenFaaS, now that has over 250 contributors on the project, aims to make serverless really simple and secure for you. Now, it's actually just been the 3rd birthday of the project, which shows how long this has been going. And this didn't happen overnight. It's taken a lot of work and a lot of energy from the whole community to build all these pieces, working with users. And the real mission, I guess, is to make serverless portable. And that's why I started this project. And the 3 values that sort of drive us as a compass point are being focused on developers. So making sure there's a great UI, CLI, that we've got good onboarding content, good samples and examples that are relevant. For instance, we had Node 10 and then Node 12 support way before Amazon. And we had a Golang template even before Azure Functions, right? And that's what we're able to do. Now, it also has to be easy to operate because you don't have 100% of that managed experience of the cloud. So there's some things that you're going to have to do, and we offset that by making it super easy to use and have this community that is built around the project. So if you're here and you're like, okay, well, you know, I've spent all this time studying for a CKA, I lost my sleep, was really stressed about it, and now I know how to do all the YAML files. Why should I care about OpenFaaS and serverless? Well, this is what it would look like if you made one microservice, okay? So you start off with, let's say, your index file, and you define all your routes and middlewares here. Maybe you Google this every time you need to write a new one, or you copy and paste an old one. Then you need a package JSON to say what dependencies you need, what specific versions. You need your actual handler for the code that's going to do something. You need a Kubernetes service. You need a Kubernetes deployment. This is a pretty short one. It probably should be a bit longer. You need an ingress definition, and you need a Docker file. And you're probably going to need a Helm chart and a few other things too, right? Like a Let's Encrypt certificate. And after all of that, you can say hello world on Kubernetes. And we think that's just way too much. It might be okay for one service, but when you have to manage a few and you've got a team, this just gets out of hand. And instead, what we can offer you through the OpenFaaS template system is simply a very minified YAML file as a bare essentials of what you need. And then all of that has been compressed down on the right-hand side to 5 lines of code. It does exactly the same thing, right? And so now what you're managing is effectively just a few tiny YAML files, and you can have multiple functions inside each one. And when you need a bit more control, you can start to bring in those concepts from Kubernetes, bit more complicated, a bit more powerful, and get some of those sharper edges back. This is what it would look like if you use the Go function in the HTTP style. And we have dozens of templates, some that we maintain in the project, some from the community. You can even write your own. This would be for Golang, and it would just print back a response. And then you can even use a Docker file. As long as you serve HTTP on the correct port, all the other plumbing, all that management that we've built would allow your requests to come in and be served. So this would be Ruby on Rails example. So going back to PLONK, you can see the stack on the right-hand side. Typically, you're going to have something above OpenFaaS, deploying functions, maybe GitHub Actions or GitLab, maybe OpenFaaS Cloud. One layer down is where you start to get to the nitty gritty. So this is where we're running OpenFaaS for your compute, for the gateway. Prometheus is going to give you monitoring and metrics, which you can also use to scale with Kubernetes. And that's where NATS is as well. So hi NATS, Thanks for the t-shirt. This is where you are in the PLONK stack, and NATS provides asynchronous messaging. And like Derek said earlier, this ability to send messages between different networks and respond to them. And then underpinning that is Kubernetes. To run stuff on Kubernetes, you need a Docker image, and you want to put that in a registry. And this is basically what you get. Now you can install the PLONK stack in 2 commands. We're going to create an installer for OpenFaaS, but then decided to create one that could work for other things like NATS and Mongo and Postgres. And so it's just simply arcade install OpenFaaS, and you'll get the whole PLONK stack, as you can see below, installed using a Helm chart. Now, if you wanted TLS as well, because you're probably going to install on your laptop to begin with, let's say it was faas.example.com, we can then use Arcade to install OpenFaaS, Cert Manager. Cert Manager gets us certificates, Nginx, server-side ingress. If you're used to Kubernetes, you might know what these things are. And then the last one generates an ingress definition for us with basically two flags, your email and domain. And now you have faas.example.com, secure serverless out the box. So let's see when that can give us a bit of power. Normally, we want to invoke a function, right? And let's say we're going to generate a PDF and invoke it over REST. We'll hit the gateway. The gateway will go to, this is a Node.js function. Maybe it queries Postgres, and then the result gets uploaded to S3. Perhaps that takes 10 seconds, okay? Then you're going to be stuck there for 10 seconds until it's done. Maybe you can write some code to start running a few requests in parallel. Not great. When you come to NATS, what you can do, what we've done, is we've added something called the queue worker. And the queue worker simply gives us another URL, like the normal one, but it has the word async in it. And then rather than running immediately, we'll put the message on a NATS topic and use NATS streaming. So the gateway publishes, the queue worker subscribes, there's just one topic right now, and then it will invoke that function for you. So we've got generate statement up on the top. Once that's run, it took its 10 seconds still. We can also put a callback. And so we've got this X callback URL on the left-hand side of the screen, and you can send that with your request. And that's where your data will then go when it's done. So if we had 100 of these 10-second jobs to do, we'd be sitting there for quite some time on the client end. Perhaps the connection isn't that stable. Like Derek said earlier, problems with TCP. Well, what we can do here is just input all those jobs up front and then wait for them to be processed and for the system to auto-scale. Now, we'll just show you really quickly what that looks like. So I've got actually I'm using a Raspberry Pi. There's no reason why you have to. You can use a cloud computer. And I'm listing the functions and have this make CA. I've used that because it just takes a long time to do crypto on ARM. It would be a good example. I'm going to get the logs of the OpenFaaS running on the server. You can see it's just running a few requests. And we'll get the logs of the function as well. And then I'm going to invoke it synchronously, and we're going to sit here and wait for it. And so this is going to go off and use Golang's crypto modules to generate a CA, generate a certificate from it for OpenFaaS Limited in Peterborough. We see we just sort of sat there waiting. It took 12.5 seconds. Okay, we can see the logs, 12.4 seconds end to end, and then we've got the output from the function below. Now, what NATS can allow us to do is simply change that to async function, and immediately it's done in 50 milliseconds. As far as we're concerned, it is, but then on the server, we can see that we've just started another request. The function hasn't even got it yet. It's not outputted any messages yet, let's say, but it's still going to be those 12 seconds executing, and then we'll get the result back. And we can scale this up. We have multiple queue workers. We can have this in parallel. And if we look back, we should get that result anytime now. The callback URL is useful if, let's say, you had another microservice or function you wanted to execute afterwards. Here, we can go and create a HTTPS URL that will just receive requests from the internet. We can copy that. And I think we had another function on there that was a little bit faster. We've got this node info one. And if I put my gateway, remote gateway in here, we can see it's just giving me what memory is available. And what I want to do is add another flag, say async, and this is instead of me doing the URL, we'll just use the CLI, and we want a header of X callback URL, and then the one that we got from the internet. Normally that's going to be one of your internal microservices or another system, not a random website on the internet. And that's already come in. And if I click on this, we can see the data's come back. We'll also probably have some headers that tell us how long it took and some other data. And it can probably say that it came from my home IP address as well. Okay. So that's how tightly coupled and well built into OpenFaaS NATS is now. We've also got logs for the queue worker, and we can scale the queue worker up and down as needed. This will run on any cloud. The other reason why you may want to do this is if you're processing webhooks, let's say from GitHub, often they will stop you at about 1 second, or maybe your client or customer will stop you at 1 or 2 seconds. If you're going to take 10 seconds, then this will just return immediately, and you can deal with the response later. So a lot of people, when they look at OpenFaaS, they get confused because we talk about HTTP. I think, well, maybe that's the only thing that's supported, and that's not exactly correct. It is supported. We also have integration with VMware, vSphere, S3, Minio, Redis, RabbitMQ, one that Derek's quite familiar with there. AWS SNS, SQS, Kafka, the list goes on. And the great thing is that you can even build your own. And that's what we did. So this is the NATS event connector. Now, before we were doing REST, but then getting the messages and publishing them to NATS and then dequeuing them and executing them over REST. Here, we're actually taking a NATS topic that's publishing messages and having that brokered to OpenFaaS on our behalf. If you look at the top right part of this diagram, there's a topic map. And this is built up basically by when you deploy a function, you say, this is the topic that it cares about. It could be one or more. And so here I can see the send funds and the email functions both care about payment created. That means we go to the left-hand side of the screen where we've got the NATS topics. The code is subscribed to both of those to payment created. When it gets a message, it will then use the connector SDK. It's what you can use too, to invoke the function via the gateway. And so that map allows us to stand in the gap and intercede. So when there's messages coming from that, we don't have to change any of OpenFaaS, messages coming from Rabbit, coming from Redis, it doesn't matter. The connector is this agnostic glue, if you like. It allows you to extend the system very quickly. So the future work with NATS I have in mind is to be able to install that NATS connector through Arcade as an app. At the moment, you can install it with Helm. The queue worker can do multiple concurrent requests, and you can scale that up. But if you had a bunch of slow requests and a bunch of fast ones, because they're in one topic, they're gonna effectively gonna have to wait because it's first in, first out. What we've been talking to the team about is how can we start to extend OpenFaaS and keep it simple. We do not want to make it complicated, and be able to have a fast queue and a slow queue, get some observability into the mix, maybe out the box or just in our docs. I know there is some stuff out there for NATS already. And then Jetstream, very interested in Jetstream that Derek announced in KubeCon in San Diego. Potentially, it could replace a queue worker, right? And there's some nice performance enhancements there. There's running a job for however long it takes, various things like that. And the event connector, again, we could have another event connector for Jetstream. So here's a couple of ways you can connect and learn. We just close up the presentation. The first is the OpenFaaS workshop. And I've not included all of the links you could ever want here, because if you go to this one place, you'll probably find what you need. It will guide you through how to use NATS and PLONK, how to deploy it, even asynchronous functions. And then in the store, we've got 10% off with code stay at home. So get yourself a t-shirt or mug, get yourself a nice hoodie and support the project. Okay. So thanks so much for your time. And I think we just hit 20 minutes.
Alex, this is Derek. Thank you so much. I've been a big fan of yours and OpenFaaS. And as you can tell behind the scenes, Alex and I have been aware of it. We're starting to work more closely with him and the ecosystem around OpenFaaS to make NATS as helpful and as enabling as we can to some of the efforts there. So thank you for the time today. Thank you for dressing up with your NATS t-shirt. Really, really appreciate it.